Assalamu alaikum. Our topic for today is data center network planning. This is a mini project for our course Computer Networks. We'll begin with a brief introduction to data center. A data center is a facility composed of network computers and storage that organizations use to organize, process, store, and disseminate large amounts of data. It is especially significant in organizations which rely heavily upon application services and data contained within a data center, making it a focal point and critical asset for everyday operations. So, coming to today's topic, what do we intend to plan today? What we have to do is we have to plan a data center for a university consisting of 15,000 users, taking into consideration at least 10 different software and services the data center network can support. So following are the areas we'll cover. The equipment we are going to use, our design, approximate cost analysis, and the topology we are going to use. Okay, so following are the equipment we are going to use. We are going to use an 8-blade server chassis. The chassis we are going to use is Cisco Nexus 7000, which will be of 4 slots. There will be 4 blades that can be fitted into each chassis. The blades we are going to use is Netra Blade X32B, and there will be one software switch per chassis. Before diving into the design, it's important to know what a blade server is. A blade server is basically self-contained computer that consists of a server rack which is known as a chassis, which and this houses numerous thin and modular circuit boards known as server blades. Each of these blades can technically be deemed as server themselves as they can often be dedicated to a single application. Only core components are present on the blade itself as efficiency is important when we use blade servers. Okay, so time to talk our design now. As we talked about, we'll have eight chassis which will contain 4 blades each. There will be 2 fiber interconnects. There will be 4 12 GB connections from each chassis to each interconnect. So there are 96 GB of in and out connection from each chassis, making it 768 GB overall. We'll also make a separate server profile inside our data center that will also be connected with the fiber interconnect. This server profile will have 3 distinct values. It will have the organization out all the MAC addresses and VLAN information and all the networking stuff in the software. Storage is provided by SAN, which is connected to the fiber interconnect, while Ethernet will also be connected to the interconnect. So here's our design. As you can see, there are 8 chassis with 4 blades in each of the chassis and 4 connections between each chassis and each fiber connect. Okay, talking about cost analysis now. Each Cisco Nexus 7000 chassis costs around $100 to $150. So as we are using 8 chassis, it will cost around $800. Each Netra Blade X32B server costs around $80. We are using 32 servers, so it will cost around 32 into 80, which is $2560. Each Cisco UCS 6300 series fabric interconnect costs around $8,000 each. So as we are using 2 interconnects, it will cost $16,000. Okay, coming to topology now. The topology we have used is multi-tier model topology. This relies on a multi-layer networking architecture consisting of core layer, aggregation layer, access layer. Okay, so let's go briefly over the 3 layers. First, the core layer. The core layer serves as the gateway where other modules connect. The other modules such as extranet, WAN, and Internet Edge. All links connecting the data center core are terminated at layer 3. Now talking about the aggregation layer. In the aggregation layer, many access layer uplinks are connected to it. It aggregates thousands of sessions leaving and entering the data center. It provides value-added services such as server load balancing, firewalling. Now coming to the access layer, it provides physical level attachment to the server resources. It meets particular server requirements such as NIC teaming, clustering, and broadcast containment. Here is the design of the multi-tier model topology that we are using. This is the core layer, while after that it's the aggregation layer, and here is the access layer at the bottom. The question arises, could we make this system with rack mount servers? The answer is yes, we can. However, we still use blade servers. Why is that? The reason being that the blade infrastructure leads to greater efficiency because of consolidated power and cooling. It reduces the number of power supplies and fans required. And due to its infrastructure, there is also an added advantage that the space is saved. Hope you enjoyed the video. Thank you for watching.